Good morning, class. Today we'll be looking at rate of a chemical reaction, SS3. As you all know that this is more of a revision class. We are preparing for our external examination. Under this topic of reaction of rate of a chemical reaction, we'll be discussing definition of rate of a reaction. We will look at collision theory. I will talk about the factors affecting the rate of collision of reactions today. Rate of a chemical reaction. The rate of a chemical reaction is defined as the number of moles of reactant converted or product formed per unit time. The numbers of moles of reactant converted or product formed per unit time. Now, mathematically, it expresses as change in concentration of the reactants or products divided by time taken for the change to occur. What do I mean by this? We discovered that by the time we are having two substances, substance A and B, to react together, there is a particular numbers of moles of A that we are reacting with the numbers of moles of B. Now we are looking at how many of A reacted with how many numbers of moles of B before the reaction comes to an end. Now, and what is the duration of time for this reaction to take place? That is what we mean by the change in concentration of the reactants all over the time taken for the change. Also, I said it can also mean the change in concentration of products. That is, if A and B react to form C and D, how many of C is produced and how many of D is produced, and what is the specific time it takes C and D to be produced. That's what we mean by the change in concentration of the product all over time taken. Now, there are cases whereby when we are dealing with substances that are not solid in nature, that are gaseous, then we cannot talk about concentration, but rather we talk about amount in volume of the reactant that is used up all over the time taken, or we say the amount in volume of the product that is formed all over time taken. So that is to say, if you are dealing with a solid reactant, then solid or liquid reactant, we talk about concentration. But when we are dealing with reactants that are gaseous, then we talk about amount in volume of the reactant. Now, this brings us to talk about collision theory. Now, listen carefully. It's not for a reaction to occur, for a chemical reaction to occur, there must be a collision between the reacting species. That is, if A and B is to produce C and D, A and B must react together. Now, in reacting together, they would tend to collide with one another. And bearing in mind that the average kinetic energy of the particles of the reactant varies from one particles to another particles. So for a reaction to occur, the reactant particles, they must collide with one another. Now, collision theory is simply telling us that there must be a collision between reactant particles for a chemical reaction to occur. But we must bear in mind that not all collision leads to chemical reaction. Not all collision leads to chemical reaction. Like I earlier said, the particles of the reacting species varies from one particles to another. The particles are not all moving or colliding at the same speed. So that is the reason why that it is not every collision that will lead to a chemical reaction. The collision that leads to a chemical reaction is called effective collision. Bear in mind, the existing reactants or the existing substance initially has its own existing bond. Now, for a chemical reaction to occur, then the bond which is in existing reactant has to be broken. If that bond is not broken, then a new product cannot form. So the existing bond in a particular reactant has to be broken before that particular reactant can convert, before its constant can convert, before its element can combine with elements of another reactant to give us a particular product. to give us a particular product. So that is the reason why that there must be a collision, and it is not all collision that leads to chemical reaction, but the ones that lead to a chemical reaction is called effective collision. Now, also, we must bear in mind also that for this reaction to occur, the energy barrier has to be broken. So it is only the collision that leads that can supply enough energy to overcome the existing energy barrier of a particular chemical reaction that will lead to a chemical reaction. Must bear that in mind. Now, what are the factors now that affect this rate of collision? The factors that affect the rate of collision: the rate of reaction. 1, nature of the reactant. 2, concentration of the reactant. 3, surface area of the reactant. Temperature of mixture. Presence of light and catalyst. Presence of light and catalyst. Let's take them one after the other. Nature of reactants. Now, we generally know that matters exist in 3 states: solid, liquid, and gas. Now, based on the nature of this reactant, when particles are in a solid state, they find it difficult for them to collide. The effective collision is somehow affected by the nature of the reactant, which has to do with their states. Is it in the solid state? Is it in the liquid state? We find out that solid state particles matters we react slowly. The rate of the reaction will be slow compared to when you are dealing with a material in the gaseous form. Reactants in the gaseous form. So the particles in the particles of matter in the solid state, we have to be energized for such a reaction to really occur, so that the particles of the reactant can gain more kinetic energy to allow for frequent collision, for the existing bond to be broken. 2, concentration of the reactant. Concentration has to do with how crowded is the reactant. We discovered that if the reactant spices are put in a particular container, they based on the kinetic energy of the particles reacting together, they have to travel a certain distance before they collide with one another. Now, in doing that, they crowd the particles are in the enclosed container, the more they frequently collide. So when the concentration of the reactant is on the high side, that is, you have much of the reactant being put together, then they collide frequently, and this tends to yield a positive result. But when the concentration is low, then the rate of reaction will be slow. Now, in terms of surface area, it has to do with what is the number of surfaces of the reactant which is exposed per unit time for reaction. Let's take a cube sugar for instance. When you look at a cubic sugar, you drop it in water, and you take a grinded sugar and you drop it in water. You discover that the grinded particles will dissolve faster than the solid particles. Now, what happened? You discover that for the grinded sugar granules, you find that many surfaces are exposed per unit time for dissolution. Why for the solid sugar in the cube form, you find out that it is the outer layer that is exposed to the solvent per unit time. Now, when the outer layer has dissolved, it will expose the inner layer, and that is how it will continue gradually until it comes to the smallest particle. So the number of surface of reactant exposed per unit time affects the rate at which a chemical reaction occurs. Now, this can be faster if the solid granules or the solid reactant is cut into bits, into smaller area, to allow for frequent collision of the particles of the reactants. Temperature of the mixture. Now, temperature has to do with temperature is the measure of average kinetic energy. The higher the temperature of a reactant, the more they frequently collide with one another. The temperature of the mixture has to do with the average kinetic energy of the particles reacting together. So when the temperature is on the high side of the reactant is on the high side, you find out that more particles will tend to frequently collide, and and particles also can gain kinetic energy to overcome the existing barrier, which is called the energy barrier, which has to be broken for a chemical reaction to occur. Now, the presence, number 5, presence of light. It is not all reaction cannot occur in the absence of light, like the case of photosynthesis. Photosynthesis needs the presence of sunlight for it to occur. So chemical reaction that occur in the presence of light is called photochemical reactions. I call them photochemical reaction. So certainly there are some chemical reactions that will not take place except there is the presence of light. The last one, which is catalyst. What is a catalyst? A catalyst is a substance which tends to speed up or slow down the rate of a chemical reaction. This brings me to talk about catalyst in two forms: the positive catalyst and the negative catalyst. The positive catalyst speed up the rate of a chemical reaction. Now, how does a catalyst affect the rate of a chemical reaction? It does that by lowering the activation energy. Now, it's just like an energy pathway, by lowering the activation energy. Let's see an energy diagram, energy pathway diagram. Now, if you look at that diagram very well, initially you can see the A0, you can see the A1. What the catalyst does is it changes the path of the reaction from A0 to A1. It minimizes it, therefore allowing for even particles of lower activation energy to be able to react and go to the product side, from the reactant side to the product side. So a catalyst tends to lower the activation energy. It creates a new path for a chemical reaction to proceed. I think we have come to the end of the class. Let's quickly go over it again. We said the rate of a chemical reaction has to do with the numbers of mole of a reactant that is converted or product that is formed per unit time. And I said that when you are dealing with materials in terms of vapor, then you talk about amount in volume of a reactant or product. That means that the SI units for a rate of reaction can either be in kilogram per minute, kilogram per seconds, depending on what the examiner. And for the assignment for the class, we have explained how the following affect a rate of a chemical reaction. 1, concentration. We're going to tell us how it affects the rate of a chemical reaction. Temperature, how it affects the rate of a chemical reaction. And catalyst, and how it affects the rate of a chemical reaction. To be submitted before the next class. Thank you.